Hello! Today's question is a very nice reduction formula question. So let's not waste any time and let's get right into it. Okay, so whenever we have a reduction formula question or an integral with the variable n in it, our best bet is integration by parts. So before applying integration by parts, I would like to split up this x to the n. So I'm going to let x to the n equal to x to the n minus alpha times x to the alpha for some alpha greater than or equal to 1. We'll figure out what alpha is later on. So I'm going to change this x to the n to x to the n minus alpha times x to the alpha. Cool. So let's go ahead and apply integration by parts now. So again, whenever we're applying integration by parts, the x with the variable n in it is usually the u. So let's try u equals x to the n minus alpha. And dv by dx is whatever's left over. So x to the alpha divided by the square root of x cubed plus 1. Du can be evaluated easily. It's just n minus alpha times x to the n minus alpha minus 1. And v is slightly more challenging. To solve this differential equation, we just have to integrate both sides with respect to x. And we end up with something that looks like this. And obviously the dx's here cancel out, and the integral of dv is just v. And boom, we have our formula for v. Now we have to evaluate this integral. And to do that, I'm going to do a quick u sub. So I'm going to let u equal to x cubed. So du is going to be equal to 3x squared dx. So now I need an x squared here so that can be taken care of by the du. So it would make sense for x to the alpha to equal x squared. In other words, alpha to equal 2. So I'm going to go ahead and change all the alphas to a 2. Okay, so I've changed all the alphas to a 2. And if we look back here, we notice that there's a n minus 3. And n minus 3 is also in the reduction equation. So this makes us more confident that alpha is indeed 2. So let's go ahead and apply the u sub. So we're going to get v equals the integral of... So du is 3 lots of x squared dx. So x squared dx here is a third of du. So I'm going to take the third out. And I'm going to put the du on the top. And in the bottom, we just have the square root of u plus 1. Because u is x cubed. And there we go. Our integral has been reduced now. Okay, so we've got this far with this problem so far. And we're yet to calculate this integral here. So let's go ahead and evaluate the integral. So it becomes third of the integral of u plus 1 to the negative half. Du, and that becomes a third. So we're going to have u plus 1 to the negative half plus 1, which is a half, times 2 plus c. And that's going to equal 2/3 lots of the square root of u plus 1 plus c. And obviously, because of integration by parts, we don't need the plus c here. So it's just 2/3 lots of the square root of u plus 1. Okay, so now let's go ahead and apply integration by parts on this integral right here. So what we're going to get is I of n equals, so we're going to have u times v. So 2/3 of x to the n minus 2 times u square root. So square root u plus 1 here, sorry, this is meant to be x cubed plus 1 because we defined u to be x cubed. So here we're going to have x cubed plus 1. Okay, we evaluate this from 0 to 1 and we subtract the integral from 0 to 1 of du times v. So we're going to have n minus 2 times x to the n minus 3 and obviously the 2/3 being outside, times square root x cubed plus 1. Okay, so let's look at this top bit first. So this equals, so if we plug in 1 into it, we're going to get 2/3 times 1 times square root of 1 cubed plus 1, which is square root of 2. So we have 2/3 square root of 2 minus, if we plug in 0, well, we have 0 here, which makes everything 0, so minus 0, which is just 2/3 of square root 2. So we can put that here. So now for this other integral here. So what I want to do is get rid of the n minus 2. So I'm going to, sorry, there's meant to be a dx there. So I'm going to get rid of the n minus 2, take it outside. It's going to be the integral from 0 to 1 of x to the n minus 3 times the square root of x cubed plus 1 dx. I want to reverse rationalize the square root of x cubed plus 1. So what's going to happen is I'm going to multiply the top and the bottom by square root of x cubed plus 1. So we're going to have this in the bottom and this thing squared on the top. And this thing squared is just going to be x cubed plus 1. We just get rid of the square root. So it's just going to be x cubed plus 1 dx. And if we distribute this x to the n minus 3 throughout the brackets, well, we're going to get x to the n with these two multiplied together plus x to the n minus 3. Okay, so let's break down this integral even more. So we're going to get minus 2/3 times n minus 2, lots of the integral from 0 to 1 of x to the n all over the square root of x cubed plus 1, minus 2/3 lots of n minus 2 of the integral from 0 to 1 of x to the n minus 3 over square root x cubed plus 1. So we have this so far. And what to notice now is that this here is just I sub n. And this here is just I sub n minus 3. Because instead of n, there's an n minus 3 here. So what we can say is, let me change to light blue. Actually, so what we can say is this thing here is I sub n, and this thing here is I sub n minus 3. So let me just clear this up. Okay, so we got up to this point where we had these two integrals and we defined them, or we noticed that they were I sub n and I sub n minus 3. So let's go ahead and substitute those values in. So minus 2/3, lots of n minus 2, lots of I sub n, minus 2/3, lots of n minus 2, lots of I sub n minus 3. Okay, so we have this so far, and now it's just a case of simplifying it down. So let's go ahead and do just that. So what I'm going to do now is move all of this here to the left hand side. So what we'll get is 3 sub I sub n. So now I'm going to move all of this here to the left hand side. So what we'll get is 3 lots of I sub n plus 2n lots of I sub n minus 4 lots of I sub n plus 2n lots of I sub n minus 3. Finally, minus 4 lots of I sub n minus 3 equals 2 root 2. Okay, so now I'm just going to tidy it up a little bit more. So 2n I sub n minus I sub n, because 3 I sub n minus 4 I sub n. And then we're going to get plus 2n I sub n minus 3 minus 4 lots of I sub n minus 3. Now we're very close to the answer. So now we just have to factorize I sub n and I sub n minus 3. So we're going to get 2 I sub n and 2n minus 1 plus, so I'm going to factorize a 2 out as well, because there's a 2 factorized here as well. So 2 I sub n minus 3 lots of n minus 2 equals 2 square root 2. And we are